Assalamu alaikum. So today is our lecture 15, and in this lecture we will continue for our discrete random variables. So today we will see the very important topic for the discrete random variable: probability, mass function, or in short we write it as PMF, probability mass function. So probability mass function, as the name suggests, it gives us the information about the probability that we calculate for the certain discrete random variable. So it is normally defined as and written as P sub x or small x of all the values for which we are finding the probability, and that is equal to probability of x is equal to x. So we can find the probability of this function. Now to understand this before going into further discussion, it's better to solve a simple example so that we can understand how we can find the probabilities and using the probability mass function. So let's look at the example. So I will paste example from the book. So example says that when the basketball player Wilt Chamberlain shot 2 free throws, each shot was equally likely either to be good or bad. So there's the basketball and a player, some Wilt is throwing shot 2 free throws. So if it could be a good throw or bad throw, each shot that was good was worth 1 point. What is the PMF of X? The number of points that he scored. So the first thing that we have to look for is the number of outcomes. So number of outcomes that will constitute our sample space. So these 2 shots could be, or 2 throws could be all bad and good, bad, or both are good. So so everyone has points, so we will make the table outcomes that we have made in previous class, and x is the random variable, we assign it some number. Now in this we will define the probability of each outcome. So let's start here. BB is BG, GB, GG. So for every good shot there is 1 point. So though both are bad points, so 0 points, 1 good shot, 1 point, 1 good shot, 1 bad, 1 point, 2 good shots, 2 points. Now the probability, each shot that was good, what is the PM, the number of points. So the probability of each outcome is not defined separately, so it will be taken as equally likely. So probability will be 1 by 4, 1 by 4, 1 by 4. Now here we can see that we have seen that 0, the range, if we just write the range, so range will be 0, 1, 2. So for 0 we have only one outcome BB, for 1 we have 2 outcomes BG and GB, and for 2 we have only one outcome GG. So if we want to find the probability for say probability of x is equal to 0, for which we say Px of 0, so it would be simply this 1 by 4. Similarly, if we want to find probability x1, which is probability of x equal to 1, so that will be, because it has these 2 outcomes BG and GB, so their probabilities will be added here. 1 by 4 plus 1 by 4, which is 1 by 2. So similarly for Px of 2, for which Px is equal to 2 is 1 by 4, because we have only one outcome GG here. So for 2. So this is how you can see that how simple it is. The probability mass function is used to define the probability of a random variable, of a discrete random variable. Remember that PMF is only for the discrete random variables, and it is not cannot be used or not used for it is not used for continuous random variable. Now this is the very brute way to find out these probabilities. Let's find out how we can write them properly. So the first method to write them is in the tabular form type of thing. So we can say that Px of x is equal to now we know the we know the values of range. So here we will have the range, say x1, x2, and here we will be having the probabilities for x equal to 0, 1 by 4, x equal to 1, 1 by 2, x equal to 2, 1 by 2, and it should be completed by saying 0 otherwise. If we will not write this 0 comma, these are commas, so if we will not write 0 otherwise it is not completed. Now if you can see, compare what we have done previously. So it is the same. We have took the range 0, 1, 2 and that is here the range, and for each ranged value, against for 0 we have the probability 1 by 4, for 1 we got the probability 1 by 2, for 2 we got the probability 1 by 4. So we have just put those values here. If you can see, this is the values that we have written. So this is very important again, because it's a discrete, so it exists only at certain points. So that's why we have to mention that the probability does not exist anywhere else. So we can represent this by graphical method very simply. So it is say 0. So we have to choose the so maximum is 1 by 2. So we can say here 1 by 2 and here 1 by 4, and here it is 0, 1. So we will not take 0 here. We will take 0 here, 1, 2. So it is our choice to take the scale. So this is x, and this is on this axis we have the PMF of x. So what we say, PMF of x, this is the PMF of x, PMF of x. Now we will just plot it here. So for 0 the probability is here, so we will present with it with certain mass here. For 1 it is here, for 2 it is here. Okay, so remember you have to draw dotted lines here, not the solid lines. Okay, so these are the masses that has been defined, which we call it as the mass function. Sometimes it is referred to as like this. So these are the masses that we have defined here, which are the here as so they are defined at a certain point, that this is the mass and this is a mass and this is a mass, and it is not defined anywhere else. So this is how we can represent this thing into here. For tabular method, again we have done it, but just for the sake of completion. But in the exam point of view, or if you define the PMF with these two things, it would be more than enough. So we can write in tabular form also. Just we have seen 0, 1, 2. So these are the range of x. So PMF of its values will be 1 by 4, 1 by 2 and 1 by 4. So this is graphical method. And this is tabular method. Okay, So I hope you have understood of the basics of this discrete random variable and how we can find the probability mass function for probability of a discrete random variable through probability mass function and how we can represent it. Now because now this is a probability model, so axioms would always be jump in wherever we are finding the probability. So for discrete random variables, the axioms of the probability are defined in theorem uh, 3.1, and similarly that we have defined the axioms for the basic probability model. So we are defining for the discrete random variable, for a discrete random variable x with the PMF px of x. So now we have the PMX of x and obviously and range Sx. So similarly we have the same things. Now we have the random variable x and the probability defining function PMF, probability defining function PMF, and the range of that or we said previously as the sample space. So the first theorem, so the first axiom 1, so you must recall what are those axioms. So for any x that belongs to the range of x, probability mass function of x is greater than or equal to 0. So similarly that we have defined the probability of any event is greater than or equal to 0. So now here instead of event we have the range, and from range we will get some values, and for that values that should be greater than or equal to 0. So axiom 2, it simply states that I think you can judge it. So the summation of all values that belongs to the range of x, if we add the PMF probabilities of the PMF, that will sum up to 1. So that can be seen in the previous example clearly here. So we have these probabilities 1 by 4 plus 1 by 2 plus 1 by 4, so they sum up to 1. So that is the second axiom is fulfilled. So that must be true. So this is the same interpretation that we have done, that probability of any thing cannot be greater than 0 or less than greater than 1 or less than 0. So it cannot be negative and cannot be more than 1. Now axiom 3. So axiom 3 says that for any event B is subset of Sx, the probability that x is in the set B is probability of B is equal to summation x belongs to B and Px of x. So if you look closely here, the first two axioms are the we have explained that they will define the limit of our probability mass function, that it will be, the probability will be between 0 and probability is between 0 and 1. Now this is the same, that if we have some event that is a subset of the range of x, so the probability that x is in the set B would be summation of this. And now the summation is obviously possible because all the elements that are in the S of x that are exist in the S of x, so they are mutually exclusive. So obviously if they are mutually exclusive, so we can say that B could be B is equal to union of x that belongs to B for x x is equal to x. So this is actually the same axiom that we have studied, that the probability of a union of a certain event for collection of events is equal to the probability of individual probabilities of that collection of events. So this is the same. Don't worry, this is just written because in this form because of it is a probability mass function. Now you can understand here that it is defined for this scenario. So so we can solve one example to understand this more clearly. So I will copy it from the book. So it says that the random variable n has PMF. We have given this PMF, and Pn of n is equal to C over n for n is equal to 1, 2, 3 and 0 otherwise. So we have to find first the constant value C. So how we can find out the constant C? So that's pretty easy if we use the definition of the axiom, so we can use it. So what's that definition? Let's go back to the axioms once again. So it says that a summation of all the probabilities probabilities in the probability mass function is summed up to 1. So here we will use the same thing. So what we can do is, for solving this A, we say that summation of all n that belongs to S of n, because here S of n is given here as 1, 2, 3. So that is P n of small n should be equal to 1. Now here it is from n is equal to 1 to 3 and P n of n. So that would be equal to simply. So what is P n of n? For 1 it is C over 1, for 2 it is C over 2, for 3 it is C over 3. So it will be C plus C over 2 plus C over 3. So which is equal to 1. So now here we can solve this very easily. So C, we will take it common, 1 plus 1 by 2 plus 1 by 3 equals to 1. So from here we can find C which will be equal to 6 by 11. So now we know that we have this C we could find out. So now we can write Pn again to complete this thing, which is equal to this. So it is C by n. So now C is 6 by 11 n. Okay, now for n is equal to 1, 2, 3 and 0 otherwise. Okay, now we can find the probability B part for n is equal to 1 and for probability of n is equal to 1 P parts. So it says that it's very simple. We have now P probability mass function completely defined. P n of 1 we need to find. So we just simply put 1 here. So for n is equal to 1 it is 6 by 11 and for n this is 1. So it is multiplied by 1. So it will be 6 by 11. That's very simple. So C part says that probability of n is greater than or equal to 2. So n is greater than or equal to 2 is simple, pretty much simple. So we have to see for equal and 2 it is defined for 2 and 3 only here. So we can write it probability of n2 plus probability of n3. So we will define these one. So we will put 6 by 11 and 6 by 11 into 2 plus 6 by 11 into 3. So this would be simply, so 6 by 22, 6 by 33. So just take the LCM and you will find out the answer. So next part is D, which says that probability of n is greater than 3. Now this is a very simple, trickier part. It gives us but this is very trivial and pretty much very simple, because if you look at this PMF that's defined here, we can see that it is not defined for other than these 3 discrete values. So if whatever we take other than these n values of n, so it is defined as 0 otherwise. So for n is greater than 3, obviously it is not defined here, so it means that it is 0. So that is pretty much simple. So I will stop here. I hope you have understood it. So I will request you to please go through some exercise questions and repeat it, and if you have any questions you can ask me in the class. Stay blessed. Assalamu alaikum wa rahmatullahi wa barakatuhu.